It's up to you if you want to have something to study from. Okay, this seems to be working now. You can afterwards. It's however you like. And it's also, I'm putting this up on the YouTube channel, so if you took a picture but deleted the picture, you can look at it later online. Okay? So, on the multiple choice, I'm going to give you numbers in different forms. I could give you fractions. I could give you improper fractions. I could give you decimals. I could give you negatives as decimals or fractions or whatever. Could you put those on a number line? Right? They're all going to be real numbers. Could you put those ones on the number line and say where they would be? What's that? Are there any fractions that are mixed fractions? That could be another one, like 2 and a third. So you have to know each of those things. Okay? You have to know how to reduce fractions. Okay? So reducing fractions, if I give you something like 4/28, the top and the bottom can be divided by 4. That's 1/7. Can you reduce a fraction? Okay? If I give you two numbers, can you find a number in between? They could be decimals. Between, right? And we had this, if we look in our, yes, and you get a calculator for the quiz. If you look in your notes, this is questions like we did on page 12 and page 13. So between 0.35 and 0.37. Yeah, that fun game where it was bigger or smaller. So this is on your notes, page 12 and 13. There's going to be some questions of what numbers are between. Okay? And we could have decimals, we could have fractions, we could have mixed fractions. So you have to be able to think about it and work with it no matter what form you have. And you'll have a calculator so you can change things to decimals and stuff like that, but you need to know how to use your calculator in order to do that, right? Calculators are great if you know how to use them, right? But we've all dealt with technology at some time where we didn't know how to use it. There's always been like, right? I remember the first time your phone like locked and you're like trying to turn it sideways and you don't know it's on lock and you're like, what's wrong? And then someone's like, oh, you just touch this and this. And then it's easy if you know what to do, right? But if you don't know what to do, it's not fun, right? And it's like, they just sent an update for my phone and now something doesn't work. That in our notes package. So page 12 and 13 out of our notes package is where you can find that. Okay, then we get to, scroll down here, shorter and long answer questions where you have to show your work. All right, so we have, can you change from a mixed fraction to improper and vice versa? So if I give you 2 1/3, that was not even close to 2 1/3, 2 1/3, can you write this as 7/3? And if I give you 12 over 5, can you change that? Yeah, some of them are just, you can just write the answer if you, it's fine, 2 and 2/5. Like, yeah, that would be fine. Just one step. And I have some that I just say complete the following. If something is worth 1 mark, it usually means on a quiz you could just show the answer. If something is worth more than 1 mark, it usually means that you should show some work and then get the answer. So I have some order of operations. BEDMAS. Order of operations questions where I want you to do one part at a time. So really, like, it's going to be harder than this, but if you had 2 plus 3 times 6, if you were showing your work, you would do 2 plus 18 to show that you would do that first, and then you would write 20. So on a question like this, I'm going to say, show your work. I need to see this step, that you know that you do the multiplication first. Question?
I don't know if I should be asking this, but just for the sake of argument, if you were to do 2 things at once,
Yes,
could you show that?
you could show that. Like if you had 2 times 3 plus 6 times 5, could you show 6 plus 30? Yes. Okay? Or as long as you're showing some things,
Or an exponent.
yeah, and you have an exponent and multiplying, you did the exponent and you did the multiplying separate, that it follows the order of operation rules, that would be okay. But there are going to be some calculator ones where I might have like 2.1 times 3.7 plus 0.5 divided by 0.7. You have some decimals to work with. And then you'd have to show that you know what this is and you know what this is, and you don't add first and then add afterwards. Okay? There's going to be working with integers and working with numbers that, like, what's something I've talked about lots in this class? I've talked about temperature. Because it's been cold and because it's something that deals with the negative numbers. So if the temperature changes from 7.1 degrees to negative 33.1 degrees, sounds like Winnipeg, right? How much has it changed? If this took 5 days to do that, it didn't just happen in 1 hour, how much did it change per day? Ooh. Right? So overall, this is about, it went down 40 degrees, right? 40.2 actually? Yeah, 40.2. In 5 days, it's going about 8 degrees per day. That's a good estimate, but we'd have to use our calculator to get the exact number. Okay? So there'll be questions like this. No, I didn't put any Fahrenheit to Celsius questions on it right now, and I also didn't put the number families. I decided we did a worksheet on that, and I didn't put the number families, but the number families will come up later on, so we have to make sure we still know that.
Number families are like the grocery store.
Yeah. We've done some questions with percentage. Yeah, you missed the first. Oh, we had the number superstore. The, yeah. We pretended if you had to put numbers in a grocery store to buy them, what section would you go buy that number in? Where would you find it? And then we complained about Superstore's organization. So percentage of a number. So we talked about, could you do 12% of 70? So we've done some of these questions, a review of how to do them. 12% is a decimal, 0.12, and anytime you're doing a percentage of a number, you're going to multiply. And these are calculator. Yes, you'll have a calculator so you can figure this out. Good mental math.
What?
8.4. You were close. You did the 0.1, you did the 0.14, but that should have added on to the 7 to get 8.4. Okay. I'm going to get you to order numbers.
Hi, sorry to interrupt.
Hello?
I have Kiana to the office, please.
Sorry, who?
Kiana Hastings?
Yeah. No problem.
Thank you.
Okay, she'll be right down. Thanks, Kiana. I'm going to get you to order numbers either from probably smallest to biggest, but I guess it could be biggest to smallest. Just read the question carefully. So if I give you a bunch of fractions, decimals, mixed numbers, whatever they are, you can change them to decimals to order them. If I give you two fractions, like 2 over 5 and 3 over 8, are these equal, bigger than, or less than? What sign would go in there? And we did that, right? We have that in our notes. We did a question like that on page 17. So basically, I mean, I'm telling you what's on your quiz, but if you looked at your notes, you would realize this is all stuff that we've done in our notes. 2/5 is greater than 3/8. If you change them to a decimal, 0.4 and 3.375, maybe that would help, right? So we have those options. Okay? We have changing decimals to fractions and vice versa. Do you remember doing this where we had 0.13 and then going, oh, that's 13/100ths? Okay, so decimals to fractions, not too bad. Fractions to decimals. Fractions to decimals. Do you remember the trick with the nines? 2/9 would be 0.2 repeated. How about 5/99? Decimal 0.5 repeated. Both numbers, and it's tricky with just a single 5. You have to add the 0. Oh, and we also did ones with like 33 or 11. 7/11. Decimal Slurpee repeated. No, multiply this. You could change it to 63 over 99. And then you get 0.63 repeated. So there will be some fractions to decimals and decimals to fractions. So if I gave you 0.57 repeated or 571 repeated, you could change that to 571 over 999. Okay? Do you remember what an opposite of a number is? What is the opposite of 3.2? Negative 3.2. It's not hard, right? But if you forget what it is, it's impossible. That's what happens in math. Sometimes you forget something, and it's like, I can't do this question at all. And then someone shows you, and you're like, you serious? I knew that. But that'll happen sometimes. Oh, and then we also have, we did it before, but percentages to decimals. Woo. So if I give you 6%, As a decimal, that is 0.06. And sometimes you can think about, well, if I got 6%, that's really like getting 6 out of 100 on a test. Don't do that tomorrow, okay? Yeah, if funny in a bad way, right, Kyle? Like it'd be like, like you got 6%, right? Yeah, tragic funny. Yes, yes, those tragic, a tragic comedy. It is out of 30 marks. Not too bad. Okay? You gotta go? Okay. Well, I put the rest of the stuff up there, and this is all the stuff gets put onto the YouTube channel so you can catch up that way. Okay? Am I supposed to, are you marked excused? Okay. So I don't have to change the attendance or anything? Okay. All right. Yeah, no problem. Okay. So, that is our 6%. All right, well, could they retest? Oh. What would have to happen to get 1 point? I don't usually give 0.8s, but maybe you get 2 out of 30, and then I deduct you 0.2 because you spelt your name wrong. Okay. Real story when I was in grade 7. I'm a person in my class, his name was Michael, and we were doing a quiz to be allowed to dissect a frog. But in order to be allowed to dissect a frog, you had to study and you had to get at least 7 out of 10 to be allowed. Michael got 6.5 out of 10, and the teacher took off a half a mark because he spelt his name wrong on the test. Doesn't that seem like, were they like the teacher really didn't like them, like looking for a reason to not allow him to write the test? I don't know. So, yeah, Michael had, he ran into a few times conflicts with teachers. Grade 5, you like Michael? Michael was sort of like, he was the one who was like, okay, he would represent the students. When we as students were fed up, Michael would take one for the team. So for example, my grade 5 teacher would always say, if you don't like the way that I teach, you can pick up your desk and leave. Yeah, he actually picked up his desk and left. Okay? We all realized you are in so much trouble, Michael. Thank you for picking up your desk and leaving. We appreciate it. But you are dead. Because you knew that if you took the teacher up on that threat, you were getting into a battle. You were gonna lose, and your parents were gonna be involved, and the principal was gonna be involved. Yep, we had. Oh yeah. Whew. Anyways, so there. Oh yeah, I had this. There was the strap still existed when I was in elementary school. Where is Michael now? I don't. Yeah, I have to find out. He's probably stalking me and watching all my videos and going, "Ah, you mentioned me." Right? Tag. All right, so let's continue a little bit in our notes package. We don't have a lot we do today. I've got a little assignment that we can work out of our textbook at the end. We are on page 25. Oh, I got lots of good stories about Michael.
I want to hear some more stories about Michael.
Michael's the one who said, I'm deciding not to take a bunch of high school classes because I want my choices in my life to be easy, so I want to shut as many doors as possible. So if you like, don't take certain things. I can't be a doctor. I didn't take the classes. That door's shut. I can't be an engineer. That door's shut. Life is good. My decisions are easy. Right now I'm going between McDonald's and Dairy Queen. No. So when estimating, remember yesterday I was like, if I want to estimate, I'm going to put a little dot there to show that I'm estimating above the equal sign. An equal sign with a dot means it's an estimate. If I was estimating this, sometimes people go to just whole numbers, okay? And you can decide which is the best estimate here. If I went to whole numbers, can you see that I could do 3 plus negative 4? That would be one estimate. And if I did that, my estimate would be negative 1. Or I might say, maybe I want to go to half numbers. Can I still do mental math with half numbers? So this one's closest to 2.5. This one's still closest to negative 0.4. Then my estimate's negative 1.5. Which do you feel is a better estimate? Maybe the 1.5 because we rounded closer. And then we would have to take out our calculator to get the actual answer. And what would that be? Does someone have their calculator handy? For the first one, 2.65 plus negative 3.81. Negative 1 point. Yes. So interesting, because we kind of thought the negative 1.5 would be the better estimate because we did a closer estimate for the 2.5, but this one, the initial one, was actually a better estimate. So that might cause you to think, well, why could that be? It kind of went against our gut feeling. I was like, oh, this is a better estimate. Well, part of the problem was when you made this one negative 4, you moved it on the number line further to the left. And when you moved this one to 3, you moved it to the right. And so moving one to the left and one to the right kind of compensated for each other and canceled each other out. Whereas if you moved them the other direction, you spread it out further. Just kind of interesting. Okay, well, negative 5.96 for an estimate, that makes sense to change to negative 6, wouldn't you agree? That's really close for estimating. Minus a negative is plus. And negative 6.83, well, that'll become plus 7. I'm going to say my estimate is 1. Sorry, guys. I'm a little particular. I was doing estimates in blue. There we go. Switch it back. Doing the actual answers in green. Oh. I tried. No? I know, but I was just hopeful. Just hopeful. Did you turn the valves on? Oh. I have a thermostat. Today was, I know, but he came from a warm class, right? We've got,
Mr. Shirk's lacking hair like me. He's not cool.
awesome,
You should have you start
shortly. Okay, it's good.
Yeah, you really called out Mr. Shirley.
Yeah,
this hair.
yeah, it's,
Trying to grow it out, but it's just not.
yeah. He needs a break. Yeah. Are you suffering from hair loss? You need a break. You're suffering from Ferrand. That's right. Okay. Here we go. Did anyone calculate the actual one for me here? 0.87 in green. Hey, our estimate was pretty good. Next one. I go -4. I like to keep this one at 1.5. That would be approximately, how's your mental math there? -2.5. And what is it actually? -2.86. Right. And these all seem like good estimates. When you're doing an estimate, you just want to have a basic idea. Right? So if they tell you something, you'd be like, wait a minute, that is way off of my basic idea. Either I need to recalculate or something went wrong. -1.25 minus 3.55. So I might change this one to -1 and this one to 3.5. A -1, subtract a 3.5. Think of your number line. You're at -1. You go back 3.5, get -4.5. And what is it actually? -4.8. Uh-oh, next one. Someone made a mistake. What happened? I mean, the negative isn't there. They didn't even do the adding right. Yeah. Yeah, $8 would have been, so obviously they missed the negative. They seem predisposed to failure. I can't write that down. You're writing that down. So they missed the negative, and the adding was still bad. Still bad. So actually, what should it be? It should be 3.5 minus 4.5 equals -1. Okay, but we're using dollar signs here, so I add those dollar signs in. The actual answer is -1. So this would be like asking the question, you have $3.50 and you spend $4.50. How much money is in your pocket? You have a -$1 bill in your pocket, a hole in your pocket. Oh, that would be interesting if they gave negative coins out that were actually hot enough to make a hole in your pocket, the right size so you lose a certain amount of money. That would be interesting. That's next level. Mm-hmm. Okay, I am going to let you do page 26 for homework. That's not, I mean, just estimate it on your own. You're multiplying and then do the actual calculations. Not very crazy hard for those ones, but I wanted to work on these word problems because word problems are a little bit more complicated. You have to read. You have to think about what's happening, and sometimes the situation makes you make decisions based on the context of the problem. Okay, so a submarine was cruising at a depth of 110 meters. So you can imagine it. I like to throw myself into word problems. I'm like right in that submarine. There's like bubbles going outside the windows. I'm enjoying life, okay? It's rising at 5.5 meters a minute for 10 minutes. Can you do that mental math? How much will it rise in total? 55 meters, because 5.5 per minute but it does it for 10 minutes. 10 times 5.5 is 55. Or we haven't written anything yet. Well, let's see what. We want to find the submarine's depth at the end of the rise. So now, I'm going to do it wrong, and I want you to tell me what I did wrong. But I'm going to try to be like following the math really good, and then we'll talk about what went wrong. Okay? So we're at 110 meters. So I'm going to do it wrong in red. Don't write this down. We're at 110 meters. We rise, so that means we're going up. So I'm going to use a plus sign. And 5.5 times 10 minutes, which we already talked about that being 55. And so I'm going to say 165 meters. You see a problem? What's wrong? Why? But it doesn't make sense to subtract if I'm going higher. That bothers me a little bit. Whew. So how could we? I agree. Oh, I like that. Right? So if you're below sea level, you're negative 110 to start off with. Now, I know that the way that you're doing would have worked, right? You would say, well, I'm going in the opposite direction, so I want to subtract 5.5 times 10 instead of add 5.5 times 10. But fundamentally, that kind of bothered me because I was like, if we're rising, aren't we going up? Isn't going up positive? Be like, yeah, the temperature rose 5 degrees. It's now minus 70. What? No. So I like the idea there of saying, since we're below sea level, we'll start with a negative number for the depth, and then go plus 5.5 times 10. Okay? And then you get negative 110 plus 55, which leaves us at negative 65. So what was the depth? And this is a word problem. The depth is 65 meters. I'm going to just put an X through this so you remember. If you did write that down, that wasn't the right answer. Okay? But the key, and the reason why when I did it wrong, that many of you went, no, something's wrong, is you did a little bit of estimation before you did the question. And sometimes that little bit of estimation can be just a little bit of, well, if I was 110 meters deep and I went up, I shouldn't be as deep as I was before. That's an estimation, even though there was no numbers involved. But when I got 165 deeper than I was before, alarm bells went off because you thought a little bit about the situation. Yes? Oh, and I did a mental math error. Thank you. Way to pay attention. Yes. It's an excuse to use my favorite eraser. I like this little tiny eraser. Negative 55. Perfect. I think I saw the 65 in my wrong answer, and it tempted me to write a 6 again. How long will it take to reach the surface? 20 minutes. Because you see, this is great mental math. You saw in 10 minutes you got halfway there. Another 10 minutes would take you all the way there, so 20 minutes in total. How much longer? Oh, good. Okay. If it continued, how much longer? So from the other one, another 10 minutes. And this shows up as a great strategy, okay? One of the things you need to do in a word problem for math is read it, solve it, and then read it again, because you might miss a little detail, right? How much longer is different than how long. But it's just changing a couple little words. So we have to be really careful when we read things and try to figure it out that way. Okay? And then, because I like to imagine things, hey, they turned the temperature on my room. Yeah, it's coming.
When you get a chance, if you just look over that, I want to show the derivation of the second sequence geometry.
Oh, okay, yeah, for sure.
I use those two formulas and see if that makes sense.
Okay. Math homework for me. Okay. Now, I like to use my imagination. So I think about this going on for an hour. What would happen if we went on for an hour? Yeah, just like your submarine like has like jetpacks and like goes out, and then you're like out this side of your window, you're flying, and then you see like the birds. And if you can if you can take an ordinary math problem, imagine yourself in it, immerse yourself in it, one of the things is you'll pay more attention to details. If you have a crazy creative mind like mine, where you like to imagine things, you can actually have some fun. And if you're having fun doing things like this, you find you remember things better, and it helps you learn things better. I can still remember, right? Now, we already determined that I'm on the edge of like getting really old, because we said, oh, you had the strap when you were in elementary school, that still existed. Yeah, so that puts you into the old category, right? But I can still remember something I studied in grade 11, history. We had to learn all the Native American tribes of the eastern woodlands, which you have no idea, probably couldn't even name one of them. But my friend and I, we made a song. Because there's a song that's like, Mick-Mac, Paddywhack, give a dog a bone. Okay? And one of the tribes was Mi'kmaq. So we're like, oh. Yeah, like, so are you ready for the song? Mi'kmaq, Malicite, Algonquin, Creole, Ojibwe, Montagnais, Beothuk. Now, one of them didn't fit into the song. The Beothuk one I had to say at the end because it didn't fit. The Iroquois weren't part of that grouping, so it was like crazy. But then the sad part is I remember that is the one tribe that, because of the colonialization and diseases that came in, that tribe actually was extinct. So like crazy, we made a crazy song, but now I still remember that information from grade 11. So if you can make your studying fun, it's amazing how much more you can remember. Yeah. Okay. Ooh. 2 wooden poles measured 2.45 meters and 1.23 meters in length. Why do you have these wooden poles? Okay, this is where you can let your imagination go crazy. You can have all sorts of fun things. Okay? But you want to make a new pole by strapping these 2 poles together, right? Because there's a bit of snow. Oh, yeah, there's snow overhanging your house. You can't reach it with 1 pole, so you want to put the 2 poles together because you want to knock the snow and make a TikTok video of the whole thing falling off the roof and crushing something. Okay? The length of the overlap was 15 centimeters. What is the total length of the new pole that comes up? I don't have any big word problems like that. I have like a temperature question I already told you. That's a little bit of, that's kind of like a word problem, but not these. So, do some mental math estimation, do some calculations, and see what you come up for this one. What is the new length? if you could just glue them together, right? If I just add them together, right? They probably break apart in the middle at the glue part, but if I just add them together, that would give me 3.68.
And then you take away 0.15.
Which makes sense, right? Because there's an overlap, so you take away 0.15. How many people got 3.53? Okay. Now we're going to draw a picture of what's happening. We're going to draw our one wooden stick here. Okay. This is the one that's 2.45. And then right above it, the other one is 1.23. So I'm going to just draw it right above it so we have that attachment point. It's not quite as long. And you happen to have some beautiful green string, which you wrapped around like that and tied. Yeah, the bow tie is very important. Okay? Thank you. Yeah, that looks pretty.
Yeah, it looks better than Weber. Yeah, better try to draw.
Okay.
The bow tie is
That's the important part. Because you don't want to tie it too tight with like a double knot, because if you want to break the sticks apart again for something else, you want to do that.
But then it might not be tightened up and then just slip through.
Yeah, and so. Okay. Tell me why now that your original answer was wrong. The one where you just said I subtracted 15 centimeters. Because would you agree? Yeah. You have to subtract two 15 centimeters because it overlaps both. So if we look at it this way, from here to the overlap part would be 15 centimeters off of this. This would be 2.3. This is our 15 centimeters, 0.15. And then this blue section from here to here, that would be 1.08 because it also has 15 centimeters taken off. So, well, the middle, you have 2.3 plus 0.15 plus 1.08. If I draw it out this way. If I add that up, I get 2.45 plus, does it work out? Is it just 15 cents off once or 15 off twice? Is it just once? Did I convince you that it was twice? Ooh. What happened? Did I draw something wrong?
No, because you still have the 15 centimeters, it's only on one.
It's only on one. Whew. So it is 3.53. Why am I tricking you? Because it's fun. No, just kidding. No,
I
it's.
had it off by long ago, but I did, but I turned the bottom because so I did the 245 centimeters
Mhm.
as opposed to, and then just took off 15.
So does it make sense, though, where you only have to take off the 15 once, because you're still getting all of either the black one, because if I take this plus this, that's the whole black one, and then the old one. But here is an example of if we draw a diagram of something and analyze it more, we're going to be more confident, okay? Because notice what I did is I said, hey, look, you could take, when it overlaps, 15 comes off of both of them. And then you were like, oh, yeah, I agree with that now. So it means that your initial calculation, where you subtracted 15, your confidence was just sort of okay, right? You thought it made sense because it overlapped, But how easy was it for me to convince you that I could take off 15 centimeters? He's like, I got it. Hook, line, and sinker. Woo! Yeah, sucker fish. Yeah, oh, perfect. You know what? One of the things that schools are supposed to teach you, like the overall arching idea of schools is that you want to be a good citizen. And as being a good citizen, one of the characteristics is you have to be a critical thinker. Okay?
I don't think you have to be good on
There we go. Perfect. I have succeeded in something today. My students no longer trust me. Perfect. So well. We're good. Okay? Sure. You can do 6 to 14. And trust me, if you don't do it, I will fail you.
I would throw 28 in on it. For their lack of trust.
Yeah, oh, right. So this is a tough lesson for me too, because now I have to go home and cry. But